Okay, so the next part of the experiment, now you're familiar with using the crow, is you're going to investigate the density of your strings. Now this is something that you need to know to calculate the velocity of the wave in the string and things like that. So first of all, we're interested, remember, in frequency as a function of linear density of the string. So we'll calculate linear density of the string. So in your kit here, you've been provided with a small piece of string. Now, that's made of steel. We're assuming in our experiment the steel this is made of is the same as the steel of the string that you're using. So we work out the density of this. We can assume then that the density is the same for all of our strings. So from that, there's a relationship, it's equation 3 in your notes, that allows you to take the density and calculate the linear density of each specific string. So obviously, the wider the string is, the higher the linear density of the string. So a length of string that's wider is going to weigh more. So linear density increases. So it's a function of the diameter of the string. So once we know the density of the string and we know the diameters of the string, we can work out the linear density of the string. So the way to do that is you're going to take this piece of string, which we assume is the same as these guys, and take it to the scale and take 5 measurements of its mass and get the uncertainty of the mass. So once you know the mass of it, remember the density is just the mass divided by the volume. So we need the volume of the string. So we assume it's a cylinder. We use the micrometer to get its diameter. Now make sure that you convert to your diameter to a radius, because when you work out the cross-sectional area of the string, which you need for the volume, you need the radius. So the volume is just going to be the cross-sectional area, which is pi r squared, pi times the radius squared, multiplied by the length of the string. So then you have the volume of the string. You have the mass from before. You can calculate what its density is. Then from equation 3, you can work back and you can measure the diameter of each of these strings and you can work out what its linear density is. That's the preliminary calculations done. Now, what we're going to look at, remember there were 3 dependencies that we were looking at for the frequency. So you have a dependency of the frequency on the length of the string, you have a dependency on the tension of the string, and you also have one on the linear density of the string. So there's 3 relationships. So as we vary those and fix the other 2, we will see what happens to the frequency dependence. And there's an equation, equation 4, which relates them in a way that we can graph and find information. Okay, so the first dependence is the frequency dependence on the length of the string. So what we're going to do is we're going to fix the tension, we're going to fix the string linear density, so the diameter of the string, we're fixing that, and we're going to adjust the length of the string using these guys. Okay, so what you need to do, and just be careful with the strings, don't over-tension them. There's really no way you could over-tension them, but just be aware that sometimes their strings could break. So just be aware of that, but it's not usually a problem. Okay, so on the this is your sonometer. So it has a couple of things. It has a winder at this end to change the tension. It has a little hook here, which you attach your string to. It has the 2 bridges, which you can adjust. It has an electromagnetic pickup in the center here, which will take your vibrating string signal and turn that into an electrical signal, which we can measure on the crow. And it also has a tension meter at the end here. So the string goes into the tension meter and we can read off what the tension is in newtons on the end of this. So first of all, place the string in the sonometer. Now very carefully, you need to basically just place one end of the string in here and one string in here and just wind this until it's tight. And you can see that the tension, you'll be able to measure the tension on here. For the first part of the experiment, you want to adjust the bridges until they're around 600 millimeters apart. Also, you want to now take the crow and plug your sonometer in. You can start to see a bit of signal coming from the sonometer there. So you're going to have to change your scale to pick up that signal because it's significantly lower than the signal coming from here. So that means we're going to have to change our voltage division. So this division, So we can turn it right up. You can start to see a signal there. Now obviously now our time division is different as well, so we're going to have to change that until we get a wave on the screen like this. You may need to adjust the Y position until it's centralized. And you can see the wave decaying like that. Now, a function that we do have on the function generator is a storage capacity. So if we press this button here, store, we can now hit the string and hit hold, and it will hold the waveform for you there. And you're able to move the X position of that around or the Y position. So in your measurements, you can now, you don't have to just try and quickly take a measurement while the wave's decaying. You can capture it and take your measurement off the scale here. So what you're trying to find here is you're trying to find the frequency. So what you're measuring is the period. So remember, that's the time. And it's at the moment, this is set to 1 millisecond division. So each one of these is 1 millisecond. Again, when we're doing calculations, we have to convert to SI units. Milliseconds is not SI. So you need to convert that to seconds and then invert it. 1 over the period will give you the frequency in hertz. If you don't do that, you will end up with the wrong answer. Okay, so you can take the hold off there. Adjust the tension in the string until it's about 35 newtons with the knob at the end there, and just read it off here. So just get one person to turn it and the other one say when it reaches 35 newtons. So then you're going to pluck the string in the middle, you're going to get a signal, and you're going to hit hold, and you'll be able to measure off here what the period is. So do that 3 times for each separation of the bridge. So you separate it at 600 millimeters there, take a measurement, take 3 measurements, write them in a table. Then you will change by a 50 millimeter increment, so move each one of these 25 millimeters inwards towards the pickup, and take another measurement, and you'll see the frequency's gone up. So do that another 3 times. So you need to do that until you're down to 100 millimeter separation of the bridges. So we're looking at going through a series of different lengths with the tension and the linear density of the string set constant. So record those and